Afternoon all. I just want to get a quick show of hands before I start. Who's actually using Git at the moment? Quite a few. Who feels like, leave your hand up if you feel like you've got a good handle on it, like you know what's going on. A lot less. Great. I was expecting this. So today I want to kind of talk a bit about Git for if you've been used to using other version control providers like SVN or TFS or one of these other centralized version control. I really want to explain how Git's different. Why does it feel different? Why is it so much more complicated when you first get started? I'm going to be doing some demoing in Visual Studio Online. So who's using TFS with Git? A couple. TFS with TFS, the TF version control? Cool. So those that you don't know, there's Visual Studio Online, which is essentially a hosted version of TFS. It was released in about 2012. Early 2013, with the 2013 release, we got Git support in TFS. That arrived on-premise and on-premises and in the cloud at the same time. And then another milestone for me was a feature called pull requests. That landed sort of halfway through 2014. So that's kind of the timeline for me of important stuff to do with Git in the Microsoft ecosystem around TFS. A little bit about me and how I got into Git. I'm pretty involved with open source. They're all my NuGet packages, plus there's more that I'm a maintainer of or help maintain. Most of them aren't maintained because no one has that much free time. But because of this, they're all pretty much hosted on GitHub. So I've been doing a heap with Git, helping people out, mentoring, and just when people break Git and get themselves into a mess, I sort of unwind it before pulling their contributions in. So I've kind of had to learn Git pretty well. That's enough about me. There's a few things I want to talk about today. First one is why. Why did Microsoft go and add Git to TFS? Then what are the main differences between like TFVC and Git, and highlight some of those conceptual differences and try and bridge that gap to give you guys a much better understanding of why Git works the way it does. And then I'll just a bit of how to use it now, what tools are available, hosts, that sort of stuff, just to close off. So the first thing is why. I think this is a really important question. I found when I learned about the history of why Microsoft put Git into TFS, I found it really quite interesting. So the VCS team in Microsoft are based in North Carolina, but they're also in Washington, Illinois. There's a guy over in Ireland. So they're all really spread around the place. And because the team is distributed, it didn't make a lot of sense to have a centralized version control system. For a long time, the Visual Studio team, TFS, was hosted in Building 44. I learned this from one of their presentations. And every now and then it would go offline during the night and no one's in Redmond to actually turn it back on or reconnect it. So the guys around the world, especially poor Martin in Ireland, they just couldn't connect. They couldn't do anything. Local workspaces was a feature that got introduced to give you sort of offline, but that's not the same as what distributed source control gives you. So distributed teams really want distributed source control. What does that actually mean? Well, if you've got TF version control and I check it out or I map it to a workspace, I get a copy just of a single commit into a folder. When I get latest, it updates my working copy in place. I can only be working on one commit at a time. If you're looking at a distributed version control, when you do the same sort of map it to a local directory, you get an entire full fidelity copy of that repository. It's completely offline. This gives you a lot of flexibility because all of the history, all of the commits, all of the branches are all contained in your local repository. I could delete the server and I actually haven't lost anything because every single client has a full copy of what's on the server. So given that they wanted a distributed story, they had a question that they had to answer. Which distributed source control should we use? Do we build our own or do we choose something out there? They made the correct decision of not building their own, which is quite, for the time, quite not Microsoft. Normally they go and build everything themselves. So started picking up some other tools, play well with other ecosystems. At the time, there were two main choices. There was Mercurial, which Bitbucket was using, and Git, which GitHub was using. And this is about 2011 timeframe. But they didn't have to make the choice straight away. They could, okay, we're going to invest in a distributed version control. TFS is very, very tightly coupled with TFS version control. It's embedded in there. Everything's tightly integrated. So there's a heap of work to sort of make TFS work with multiple source code providers. About 12 months later, there was a startup called GitHub that was starting to make some traction. And Bitbucket was sort of going down, GitHub was going up, and that gave them some good metrics on which way to go. There's a great blog post on around 2012 from GitHub, just sort of what the GitHub Octaverse looks like in 2012. And you can see the growth rates of both of GitHub. It's quite crazy how quick it was growing. And they're just the stats from 2012. Since then, it's grown enormous. So with this sort of growth, it was very clear that the community was flocking to GitHub, which is a Git host. And because GitHub only worked with Git had that momentum behind it. Everyone was learning it, and it became the obvious choice. So the next thing was, okay, if we're going to pick up Git, are we going to do our version of Git, or are we going to play well with the community? Because at the time, Git really worked well on Linux and Mac, and it was pretty terrible on Windows, to be honest. So they were kind of tossing up, do we go try and bring all of these Linux kind of tools to Windows? And they ended up implementing full fidelity Git, which plays well nicely with everyone. So this is kind of what we ended up with. You've got all of these different tools like Team Explorer and the different providers. So Team Explorer can now talk to both the TFS version control or the Git version control. And then inside the Team Foundation server, or VSO, you've got sort of multiple projects, and then they can choose which VCS repository they want. But the main thing is that Git is completely fully supported. It's not this bolt-on. There was an intermediate tool that you could use for a while called GitTF, which allowed you to check a TFS version control repository into a local Git repository. That's not what they ended up doing. They've got a full fidelity Git server, so you clone and everything works well. So now TFS natively supports TF version control and Git. That's a bit of the history and sort of why. Now let's get to the meat of it. Sort of what's the fundamental difference between these two? Go back to what I had before with TFS or TFVC on the left, and it maps to a local workspace, and then I've got Git and my clone on the right. TFS has incrementing change sets. Because it's on the server, it can increment, whereas, and then the other users check out their own copy. I can then commit and push another change set up into TFVC, and then the other person can get latest. So it's I work, I push it to the server, and then someone else fetches it down. It's quite an easy workflow to understand, and it isn't really fraught with danger because it's so simple. Git, on the other hand, the way it works is it can't have incrementing change sets because we're all distributed. So it has something called a SHA, and it's a cryptographic hash of the content of the commit. So that's what I just said. So given that, now we've got, we don't have change sets, we've got just commits which have a SHA attached to them. I've got 3 commits in my local repository. When I clone, those 3 commits end up in my local, right? I can then commit locally, so add more commits into my local repository, and then you've got a secondary operation which pushes those commits into the remote repository. So instead of just committing and that goes straight to the server, you've got 2 operations. You now have to commit and then you share those changes with the server. This also means that if Dave clones the main Git repository, he gets everything. He can then create his own commit, and my clone over here, I can actually pull or fetch his changes from his repository directly into mine. You don't have to go via the server. This is the distributed nature of Git and other distributed version control systems. This is not a typical workflow. You barely ever fetch and move commits from other people's workflows. You tend to have a central Git repository. Git's about content. So I said that each commit is a hash of the contents of that commit. It means that when you commit in Git, that's actually a snapshot of your entire repository at that point in time. Whereas TFS, when you commit, it just stores the delta. What have I changed in that commit? And the way you get to the current state in TFS is you can just play all of the deltas from beginning of time to where you are now, and that's your current state of your repository. All Git commits are just snapshots of the content at that time. So there's a fundamental difference in the way they actually store commits. What that actually looks like is, say I've got a README in my repository. I've got TFS here, TFVC, and I've got Git. In TFVC, you'll see my README and the sort of lines added, and it's sort of a patch file. It says that these 3 lines were added at index 1, whereas Git just has the content of the file. I changed the description in my README. What TFS will do is it will have a diff, which is I want to remove the some description line and add a better description at line 3. Something along those lines, conceptually. Git just has a different SHA, which is the hash of the content, and it just stores the content. So it ends up giving Git a really, really interesting profile in terms of how fast it can do things, how cheap branching is, and a bunch of other things we'll get to very shortly. The next thing is starting to get a little bit deep, so it's not required to understand. So if you aren't following along, just have a look at the picture of the cat. So when you've got a file in Git, the lowest building block in Git is called a blob. And the blob is, say this is my license file, the SHA is a hash of the content of that file. I then have another blob, that's my README. It's the SHA of that is the hash of the content once again. The next building block up is a tree, which is essentially a directory. And it contains a lookup of what the blob is and the SHA. So I've got license.markdown and readme.markdown. That exists in a tree. Trees can reference other trees. So because they can reference other trees, the SHA of a tree is a hash of all of its children's SHAs. So what that means is, say I have a folder with my source code in it called src. This tree here is just src, it's referencing a tree, and that's the hash of that tree. This is how Git's change tracking works. This was really one thing. Once I understood how this worked, it was my point of, Git's starting to make sense to me. Other people have different triggers of when they understand Git. This was mine. And then finally you have a commit, and commits have their own SHA. So everything's just based on this SHA-1 hash. And what all a commit is it just has a parent, which points to another commit. It has a tree, which is a reference to the root tree of that commit, which ends up just going down for the entire snapshot of the repository. And then it has a committer and an author. Git differentiates these two things, not really important. So that's at a deep level how sort of Git actually internally stores stuff. As I said, not super important, but as you start learning about how branching and things work, things start falling into place a little bit. Because Git's all content-based, it actually doesn't track renames. So in TFS, if you rename a file, there's a move command. So TFS actually knows that this file has moved from here to here, and that's a rename. Git doesn't do that. Because Git is all based around content, it just has heuristics. If there's a delete and an add, and it compares those files, if they're within a certain percentage of difference, Git's just going, oh, well, they're probably the same thing, and just treats it as a rename. So it's really clever. So if you're doing these massive refactorings and renaming solutions and moving things around, generally, Git just works. You just rename all of this stuff, it tracks it, and then when you go to merge, it just works. It understands all of this. You don't have to tell it what to do. Yes, so that. Next thing I want to cover is sort of workspaces in TFS, because now that we have a bit of an understanding on how Git stores things internally, what does a Git repository? I clone it and I've got a Git repository on disk. What does that actually look like? In TFS, we have our TFS repo, or TFVC repo, and I map it to a folder. I can then create a branch inside my TFVC repo, and that gets mapped down to a folder. I can then have a folder on the server which contains more branches, which then get mapped down into folders once again. This is why TFS's branching structure is so heavy, because every time you do a branch, it copies the entire folder, and you get these like an entire duplicate of your code base. Git works a little bit differently. When you clone a repository, you clone it into a directory. And when you clone a Git repo, you'll notice there's a .git hidden folder in that directory. That contains the entire repository. The folder then becomes the working copy. So that is whatever you're currently looking at. So the current branch or whatever. We'll cover the exact terminology in a sec. So I've got a bunch of commits in my Git repo that I've just cloned. I then have two branches. I have master and feature foo. All branches are pointers. So master is just a file on disk, and we can have a look at this later, is just a file on disk that contains a SHA. That's all a branch is. It's just a pointer to a SHA. That means if I branch off master, it just costs creating a file on disk. There's not this massive overhead. This is why when people are talking about how Git branching is really lightweight, this is why. The next concept is something called the head. Now, the head is where your working copy is currently pointing to. So when you check out a branch, it updates your working copy with the content of that branch, and it points the head at whatever that branch is. So as you're checking out different things, the head just moves around, and it's just a pointer once again, but it doesn't point at the commits, it points at the different branch names. So let's have a quick look at Git branching. If there's any questions as I'm going, please just put up your hand and I'll take them as we go. So I've got a really, really simple console app. I'll just quickly run it to show you what it does. It's just a to-do list. So I can just say, hi, Ignite, and then I get hi, Ignite back. And then I can just go to, and then it adds to my to-do list. So it's just a really, really simple console app. What it looks like is I've got a program. Can everyone see at the back the font's good size? Cool. It's just a little loop that just keeps asking you. And my domain looks like this. I've got a to-do item, and then I have a to-do list. I've got an add method here, which takes a title. So what I want to do is there's two changes that I want to make on two different branches. So what they are is, the first one is I want to add a due date for this, and the second one is I want to do a refactoring. So Git branching, I said, was really, really lightweight. This little thing, if you're using Visual Studio 2015, you haven't seen this. This is the release candidate of 2015, so if you're running the pre-release bits, you'll see this. The Git tooling keeps getting better. So I'll just say I want to create a new branch, off master, and I want to call it feature due date. I'll create that branch. I'm now on feature due date, super quick, and it doesn't create a copy on disk. And all I want to do here is just say date, time, due date. And then I'll pass this down into my to-do item. Oh God. I'm using ReSharper to add that. So now I've passed that through into my constructor, and I'll initialize a property called due date. Quite easy, simple change. Now down here, when I ask for a read line, I'll just say due date, and I'll wrap that in a datetime.pass. I'm not really worried about error handling at the moment. Is everyone okay with this demo? Everyone's following? Cool. So if I run this, it should ask me for my due date. Hi. Oh, what have I done? Sorry? That one? Right, yes. Perfect, thank you. Live coding, always terrible idea. So we go hi, and then the due date will say 2015, 11/18. Cool. So that's now got the due date. I want to commit that. So I'll switch over to changes and say added date time, or added due date. Cool. The next change I want to make is I want to switch back to master, and I want to do a refactoring on a different branch. This is just to give you an idea of how lightweight branching is in Git. So I want to do another branch, which is feature refactor. The refactoring I want to do is quite simple. Instead of passing in the parameters here, I want to just take a to-do item. So every time I add something, I don't really want to change the method signature of add. I just want to pass it straight through. So down here, I just go new to-do item and pass the title in. So really simple refactoring, quite nice, and I'll do the same thing. I'll commit this. Cool. So now if I just go view history, you can see that I've got my refactor branch, and if I, this is terrible view. I use Git extensions. Here you can see that I've got two branches and they've diverged. So that gives you an idea of sort of the lightweight branching model in Git. Any questions about that? Yes?
When you commit with the TFS, you can add a work item.
Yep.
So can you do the same thing with TFS?
You can. So the question was, in TFS, when you commit, you can associate work items with that. In Visual Studio Online and TFS with Git, it works from the commit message. So you go hash and then the TFS version work item number, and when you push that to the server, it will create the association. So that was a quick look at branching. We'll pick that up again soon. So there's something that I didn't really show there, which was staging files. TFS, when you haven't staged anything, it just will automatically commit it for you. It hides this concept from you. In TFS, you've got the included and excluded files. Git has a similar concept, but it's much more powerful. It's called the staging area, or staging files. So say I have a readme.markdown, and it's unsaved. When I save that, what will happen and add it to the Git index, it will see this as a changed file. So when I add that into the index, it will actually create that blob. It'll add it into the Git's repository, which then, because the hash of the blob changed, any trees referencing that will have their hash changed, and then any trees referencing that tree will have their hash changed. So it just continually bubbles up, and that's how Git's change tracking works really effectively. So I save that file, it creates a blob inside Git, so then that thing can be tracked, and it runs up the levels. Then when you create a commit, all it does is it just creates a new commit and points to that new tree that's being created. The staging area, I said, was very, very similar to including and excluding files in TFS. The difference is that you can actually stage individual lines and portions of a file. You don't have to stage at a file level. It's about the content. This also means that you can stage a file, not commit it, make further changes to that file, and if you committed, the changes you made after you staged that file will not be committed. You've got two separate things. So you've got this intermediate working area, and this often confuses people. When we drop down to the command line later, I'll show you how this works. So we've covered staging changes and committing and branching, sort of some of the fundamental building blocks. All of these have been local offline operations so far. So everything I've done has not touched the server. That's all on my local machine. That's pretty cool. But now someone else has been working and working on this repository with me. I need to get latest. I need to understand how, pull those changes down into my local repository and actually bring my working copy up to date. So what does getting latest look like? It's quite easy. If I've got local changes, just put them aside and update the working copy with what's on the server. I then just apply my changes on top. That's if you've got changes. Otherwise, just update my local working copy with whatever the server's latest commit is, right? That's how get latest in TFS or SVN essentially works. It gets a little bit more complicated. I have my remote repository here. So this is my Git server. I've got a single branch which has 2 commits on it, and that's master. Master is kind of like main or trunk or one of those as a convention. When I clone, I get my own local copy, right? New thing is this guy here, the origin master. Git tracks local branches, so branches in your local repository, versus what it knows about remote repositories. So when I clone, it gives me a local master branch, but it also can see what's in the remote master branch. So if someone else pushes to master, I'm now behind. I can do an operation called a fetch. And what a fetch does is it downloads all changes. So it'll pull down into my local copy new branches, new commits, new tags. It'll pull down everything from that remote repository to bring my repository completely up to date. Because remember, with distributed version control, I have a full fidelity copy. So now my master is behind origin master. So I need to update that. If we drop to the command line, we use a merge command to do this. And you can merge remote branches into local branches. You've got those two, local branches and remote. So when I do that, it'll say, okay, I'm updating from this SHA to this SHA, and it says something here called fast forward. Now, fast forward just means it's moved the pointer. That's all it means. This is something that initially confused me. What the hell's a fast forward merge? All it means is that there hasn't been a merge commit. It's just moved my master along. Fast forwarded in. But there's another scenario. Same scenario, master's moved along, but now I've committed locally as well. So we've actually diverged. Someone's pushed to master, and I've also committed to master. Obviously, I can't do a fast forward merge here. It doesn't work anymore. So when I do the fetch, this is when you get the diverging history. It's pulled all those changes down, and I can see my remote branch has diverged from mine. What I need to do is I need those two to come together. So this is when I run the same merge, except I get another commit, which is a merge commit. And that brings those two branches together. Any questions so far? We're all good? Great. When I push my changes, that whole tree goes across and moves the remote master along. So then anyone else can do the same thing. You'll notice that the split in the graph has actually gone to the server. It ends up with a fork in history. You can visually see that. Here I was going fetch and merge as two separate operations. In Git, and when people are teaching you, often they'll just say you pull changes, which is git pull master. I want to pull the changes from the remote master into my local one. Pull is a fetch and merge in one operation. It's just a convenience method. So that's kind of how we get latest. I'll show a bit more around that later. The next thing I wanted to do is talk about code reviews. So we've made those changes. I've got my local branches there with my refactoring and my date added. I now want to get these changes into the remote repository. Because I'm working in a team environment and an agile environment, I haven't used pair programming or anything to get these changes in. I want someone to review it. In TFS, we have code reviews. And the way that works is you shelve all of your changes, and then you create a code review for that shelf set, right? Git has something called pull requests, which in my opinion are probably one of the reasons you want to switch your team to Git. The distributed stuff is nice. It enables a bunch of different workflows, but pull requests is one of the things that ends up changing teams for the better over time. It introduces a heap of subtle changes in your team around, I can commit multiple times and then send all of those commits into a single review. I don't have to worry about building up this entire massive change set and then pushing it to the server at once. So what does pull request actually look like? Well, when you're using pull request workflows, you never commit to master. You never really use your local master branch. You always create a feature branch. So you saw that in the to-do app, I created 2 feature branches. I didn't commit directly to master. I can then keep committing multiple times to my feature branch until I'm ready, it seems like a very small thing, but in TFS, you've got to do that entire big change set. You can't leave it in an not compiling state. Whereas if I'm doing TDD or something, I can easily write my tests, which don't compile, commit that, then make them green on the next commit. If that's your workflow, Git allows you to do that. So then you push that feature branch into the remote repository. So now the Git server can see 2 branches, master and feature foo. We'll jump it back to my demo and show you where we go from there. So my refactoring feature, I want to push that up to the server. So I've got my console here. I really like using the console with Git. But this entire presentation is kind of tool agnostic. You can use you can hopefully take all of these learnings and apply it to whatever tool. You should have a better understanding of what Git's doing underneath the tool. So Git has a concept of remotes. That's how you actually talk to your server. You add it as a remote server. So what does that look like? I think it's V, yeah. So I've got a remote there called Origin, and that's pointing at Visual Studio Online. So if I want to push this feature up, I can just push to Origin and my feature refactor. So I'm going to push my feature refactor branch to Origin. Hopefully it doesn't prompt me for credentials, because then I'm in trouble. Good. So that's created a new remote branch. Who's seen Visual Studio Online? Excellent. I just realized I don't have a master branch, so I'm sorry about this. For those that use the command line and jump around in branches, if you go git checkout minus, it goes to the last branch you're on, little tidbit. So what I want to do is I want someone in my team to review this. So I'll create a pull request, and I want to merge feature refactor into master. So I've only got one commit, but this could be multiple commits. And then you can see this is the change I've made. Quite a simple one. So I'll create a pull request. The pull request workflow is essentially, I have a bunch of commits. I want to merge them from this branch into this branch, which means you can let the server do the merging for you. We can see here that it's merging without conflict, and if I introduced conflict, then I'd have to fix that. To merge that in, after everyone's gone through, they've reviewed it, you can say, I'll approve that. You can put comments on individual lines and those sort of things. So all of that's well documented. So we've gone through the review process, everyone's happy, so I complete the pull request. I don't need the feature branch anymore. If I could actually tick I can't tick that, I don't know why. So I'll complete the merge. Merge in progress. Great. So now I've merged my feature branch, I've gone through the pull request workflow. This will revolutionize your team. It really is a great workflow change. Any questions around pull requests? We're all good? So what happened? A pull request essentially is that request to merge. So what it's doing with those dotted lines is giving you a snapshot of what will happen if this pull request is merged. So those two will come together. When I merge that, those will become solid, and then it will move master along. So that's all a pull request does. It lets the server perform that merge for you. Gives you a really nice workflow because you can see that, okay, feature foo came out, I worked on it, and then at some point we merged it in as one big unit of work. After that, you can delete feature foo. Now my local copy is behind because master, I've had my changes merged in, and I need to get those changes. So I'll check out master on my local branch. So I've made master bold to sort of indicate that's where the head is currently pointing. So I check out local master, I do a fetch, which moves my origin master remote branch along so I can see what the remotes are doing. And then I do a fast forward merge to bring my local copy up to date. So there's more steps, but this is the equivalent of your get latest change sets workflow. Except I've done code reviews and I've been able to switch. So I've been able to do a refactor, and I've been able to add a feature at the same time with neither of those changes going into the main repository, and I haven't had to use shelf sets. So other people in my team could actually collaborate with me on those features. Does that make sense to everyone? then I get rid of my local. The next evolution of this sort of workflow, which is probably more natural in terms of the end result to TFS developers, or TFVC developers, is rebasing. This is where a lot of Git, when people are learning Git, they look up rebasing and they're like, whoa, this is way too complicated. Why would I even go near that? That just looks like scary. It's actually not. Rebasing is very, very, in essence, it's exactly the same feature-wise as a get latest in TFS. What I mean by that is if I've got my local and remote repository, I fetch to bring my local changes down. So this is a scenario we had before where our histories diverged. All a rebase does is it picks up my commits from the point that those two branches diverged. So it'll look at the common commit between these two branches, and then it will just pick those commits up and reparent them. So when I was talking before about Git is all about content and snapshots, and a commit's really simple. It just points at a tree and points at a parent. All rebasing does is just reparents each commit. And then as it tries to do the merge of the content, you can fix any of those things up. I'll show you what that actually means in practice in a minute. So I've picked up my commit and I've put it on top of the remote master branch. So now I've got, if I push that, it just adds a commit to master and continues on. So I get this nice linear history. I don't have that diverge and then merge back in. And if you think about get latest in TFS and you've got local changes, it kind of just puts your local changes aside, updates your working copy, and then reapplies them on top, right? Rebasing is just doing that, but potentially for more than one commit. It just does commit at a time. And that's all rebasing is. Git has a handy little helper for this. If you go git pull master, you can just go -- rebase, and you'll get this behavior instead of the merge commit. It's really up to your team which way you go. Some people hate going down the rebase. Other teams only work around the rebase. But it's a good thing to understand. So we'll have a look what rebasing actually gives you when it changes over. So we're back here. I've merged my pull request. So I want to fetch down my changes. So you can see my origin master has moved on. So what I want to do is I want to check out my other feature, my due date feature. Let's quickly have a look at the history. So my history, can everyone see that at the back? It's not too small? We're good? Good? Cool. So you can see my origin master's moved along, and I've got that refactoring feature and my commit's sitting there. And those aren't compatible. We saw the method signatures change. So what does a rebase look like? In my program here, I've got the due date. I want to merge these together. I want to get my change in, but obviously they're going to conflict. So all rebasing is git rebase origin master. So you can rebase on local or remote branches. I'm going to rebase on the remote branch. So I've got a merge conflict. I'll say I want to merge these two things. And in TFS, it's popped up. Similar to if you have a merge conflict, you just get a merge tool. You've got to resolve it. I want to take the refactoring, so I'm going to take the right-hand side and say, nope, I want that method. Continue down. Okay, that's fine, the constructor, there's no conflicts there. Yep, property, added property, I want to keep that. Continue down here. I kind of want both changes. So what I'll do is I'll take the right-hand side one, and then I'll just change the constructor so to due date. Quite an easy change. The diff tool, as a side note, in here is really cool because you get IntelliSense while you're doing your merging. It's kind of nice. So I've resolved that. I've actually made the two changes compatible. I'm going to accept that merge. Cool, all those merge conflicts have gone away. And once you've resolved those conflicts, you can just tell Git to continue the rebase. Okay, it's applied. Sorry?
So what happens if you can't resolve the merge then and there? Can you roll it back?
Sure. So if the question was, what happens if I can't resolve the conflict? Right then, I need to go talk to someone or whatever. Instead of continuing the rebase, you can just go git rebase -- abort, and it will go back to wherever you were. So now my changes, I've got both in there. It's all nicely compatible. I'm going to jump back to the history and refresh that. And you'll notice instead of the changes going from initial solution and then my due date being off the side, it's now on top of origin master. If I have a look at the diff is really nice. It just shows me adding the property, adding the constructor, and then adding the feature. The original commit that I did where I added it to the add method, that's not in history anymore. I've rewritten history and that's just gone. I've made my change look like it was written after those refactorings were done. This is the power of rebase because you end up with a nice history that's much, much easier to follow. Rather than I've made all of these changes, someone else has made these changes, you bring them together and you get a big merge conflict, you resolve them all, but in history you still have those two things which don't make sense. You had to unwind them at the merge level. Rebase makes all of that go away and it makes your history far, far easier to understand. Everyone okay with that? That sort of analogy and everyone followed with the playing on top reasonably well? Cool. The first time you hit a scenario like this and you do a rebase in your own solution, you'll just be like, oh my God, this is the coolest thing ever, and then you'll get addicted. Git is really addictive. Who's met a Git fanboy before? Yeah, I'm a bit of a Git fanboy. So the difference between merge and rebase is just history. That's all that ends up being different. What we had, if we did a merge, we would have had what was on the left. With a rebase, we have a nice linear history and all the commits make sense. The next thing I want to cover is still around rewriting history and as a concept of reset. So when in Git, you might commit something and then go, oh crap, I didn't want to do that. Reset is the command that allows you to pop that commit off into your working directory. There's a switch for it, which is hard. Now this is one of these things that is here be dragons with Git because it just blows away those commits. So if I ran git head squiggly 4, which means wherever I am now, go back 4. It will just delete those 4 commits and then move that down. That was supposed to go one more. Whoops. You get the idea. So you can just delete commits, rewrite history, and then I can make things look the way I want them to. There's some other more powerful history rewriting commands, but those are just discovery over time. That leads me to, yes, question.
The last slide that you just showed, is that happening on your local master?
Correct. So the question is when I run a command like this, is this only affecting my local? Yes. The only commands in Git which talk to a remote are fetch and push and pull. It's just those 3 talk to remotes. Everything else in Git is all to do with your local repository. There's a command line argument that I'll talk about later, which if you then tried to push this, Git will just tell you no, because the history has diverged and Git doesn't let you rewrite history on remotes. But this is really useful for, I've committed some stuff to the wrong branch, I do a branch and then I want to delete those off master. That's the scenario that you'd use that for before you've pushed it. So Git's really powerful. I can rewrite history and do all of this amazing stuff. It's also the safest VCS to do this stuff. It has a feature called the reflog. And a reflog in Git is a history of every state that repository has ever been in. So if I do that reset, you can see that I've gone initial commit 1, 2, 3, 4, 5, 6, 7, and then I've run a reset, moving head to squiggly 4, which you can see commit 4 is head at 4, which is 4 before the top one. This reflog happens after this. So if I accidentally did that, I can actually use the reflog and check out any of those hashes that I've deleted and get back to that thing that I could no longer get to. Because Git's just pointers. All branches are is a branch name pointing at a commit. Deleting a branch is just deleting that pointer. All those commits exist in the repository still. They stay there until Git does a cleanup. So similar to the .NET. No. So the question was, when you push, do these commits that you can't see get pushed? No. So only reachable commits will get pushed. So Git's really cool. We can rewrite history. We can enable all these really, really cool workflows. And it's also safe. That comes with a caveat. If you go git reset hard in your working directory, it blows all of that away and you can never get that back. So never do a git reset hard when you've got stuff in your working directory. Always commit it and then use reset to delete that, because at least you can get back to it if you want it later. There's a few other concepts that I wanted to map across. First is shelf set. Git has a similar concept to a shelf set called a stash. But because we're not talking to the server all the time, a stash is simply a local version of a shelf set. I just go git stash, and it moves whatever's in my working directory into the stash. If I make more changes and then stash it again, it just puts it on top of the stash. And then I can pop things off the stash one by one into my working directory. It's just a stack. And it is local, so you can't push changes that are in your stash. You have to pop them and then apply them, commit them, and push them. Next one is label. Label is the equivalent of label is a tag. So I just want to tag a commit, and a tag is essentially the same as a branch. It's just a different type of ref. So if I tag, it's just a pointer, once again, at one of the shars. Much the same as a TFS label is just labeling a particular change set. Tag is much the same. A couple of other things that are features in TFVC that you might be using, you might not be using. Gated check-in doesn't exist. Because you're committing things in your local repository, the server can't get involved and prevent you from committing that locally. And then because you're pushing local commits, it doesn't make sense that 3 commits ago violated our gated check-in policy. And how do you fix that? You have to rewrite history. It doesn't really work. File lock, once again, everything's local. You can't lock a file and stop someone from editing it. You have full control of your local repository. The only point that you can enforce things is when you're talking to the server. Same with check-in policies. You're committing locally. You can't enforce check-in policies. Instead, which is, I think, in my opinion, is much, much better, is you can have pull requests be built by a CI server. So someone pushes up a pull request, it can build on your CI server, run all the tests, and then you get a little green icon in your pull request saying, this CI build committed successfully. VSO then and TFS have different rules you can enforce. So you can say, you cannot merge a pull request if the build's failing, things like that. So that's the equivalent of these things in Git. There's 2 more awesome commands that are sort of now getting into the real advanced usage of Git. The first one is git bisect. And the scenario where you would want git bisect is, okay, I've got a bug that was introduced sometime in the last 3 months. I have no idea where it was introduced, and there's 1,000 commits between here and there. If you can write a test or something that allows that you can quickly compile and then run your application and verify if that bug was there, you can then say git bisect, run this command, and find where my bug is. So what it'll do is it'll go in the middle of those two commits, check it out, run your command. If it succeeded, it goes, okay, well, clearly the bug was introduced after that point. It'll then go to the middle again, run it again, and it'll continue finding it down, then says, here is the commit that this bug was introduced. Awesome feature when you need it. The next one is interactive rebase. So we saw rebasing, that I could replay my commits on top of what's changed on the server, reparent them. An interactive rebase gives you full control of that. So you can, as it plays the third commit, you can tell Git to stop. And then you can go into Visual Studio, edit, make more changes, rename a couple of things. Then you can say, okay, I'm done with editing that commit, continue the rebase. And it will then apply your other commits after the edits you've just made. You can manipulate history in the way you want. So it's exceptionally useful in the scenarios when you're pair programming or you're trying to figure something out, where you've got a couple of false starts. I've started writing the feature, and then I've refactored it, and then refactored it again. I can squash all of those into a single commit. Really, really handy. Any questions on, yes? So the question is, the changes that I made, I've stopped on a commit, the changes that I've made, do they go into that commit? Where do those changes go? So where they will go is they'll be changed in your working directory, and then all of the changes for that commit will be in your working directory. The ones that were there before will be staged. All of your other changes will be unstaged. So the way you get them included is you stage the modifications you've made. And then when you continue, all of those changes get included. Really powerful feature. I love it. I use it all the time. And it's one of these things that you start really getting excited about Git when all of these things click and you realize these workflows that you can do that, okay, I fixed this bug in this feature. I now want to separate them to get this bug into master without getting my feature in. You can use interactive rebase to pull that bug out of your feature branch and apply it somewhere else. Really, really powerful concepts. So I've now sold you on Git, hopefully, and not completely confused you. It's a pretty broad topic, and it's also one of those topics that everyone I talk to that really enjoys Git, it's like, when was the moment that you got Git? And everyone's story is different. Some people talk about, oh, I love using graph databases and I love graph theory, and when someone explained that Git was a directed acyclic graph, oh my God, that made so much sense. Other people, it's like, well, what are you talking about? I don't really care about graph theory. Everyone's different. So I kind of tried to show you a broad range of all of the different concepts and how they map. And for me, the SHA thing really, and the fact that it's just like hashed content that gets, and there's pointers, everything's just pointers, kind of made it stick for me after a while. So you now love Git, you want to use it right now because you're excited. And the best way to get involved now is open source. I spend a heap of time doing open source. I've got a lot out of it. And the reason I do so much open source is I use these open source projects on a day-to-day basis. I work for Redify as a senior consultant, and I go into clients, and each client has different problems. And I use open source libraries all the time to solve these problems. Open source is such a big part of our industry. So getting involved in open source happens to be that majority of the open source community lives on GitHub. This is sort of a testament or proven by the fact that recently the .NET framework was open sourced. It's on GitHub. Roslyn, the new compiler in 2015, it's open source on GitHub. And these Microsoft teams are actually using GitHub to collaborate, and you can submit pull requests to .NET and Roslyn and NuGet and all of these cool things you use day to day. You can actually submit pull requests to that using the flows that we've learnt today. A great repository is GitHub Microsoft.net. Inside this repository is a list of a whole heap of .NET open source projects to get involved with. Massive list of all different types of projects, and yeah, lots of different projects to pick from. There's two other resources I wanted to share. The first one is upforgrabs.net. The idea of this is I haven't submitted a pull request before. This open source thing is a little bit scary. I don't want to bite off more than I can chew. So the idea of up for grabs is project maintainers can mark individual issues as up for grabs. These are issues that have been triaged, they've been explained properly, they're ready to pick up. So you can go to upforgrabs.net, you can filter by language and type of project and whatever, and it will tell you what label to look for in all of these different projects. The next one is yourfirstpr.github.io. This is a thing that Scott Hanselman and a few other people have been working on, and the idea is an even simpler version of Up for Grabs. Generally, Up for Grabs is, I want someone in the community to do this feature. It's an important thing, but someone in the community can take it. Your First PR is designed, there's a spelling mistake in some documentation. It doesn't matter if it doesn't get fixed, but it's a perfect candidate for someone who hasn't done open source before to just pick that up and get used to the workflows and the way you do open source contributions. Tooling is one of those things that a year ago was a really, really terrible story, especially on Windows. It's constantly improving. The Visual Studio integration for Git is actually getting really much, much better. It supports rebasing now. It's going to start adding more and more features over each release is just going to add more features and just continue to improve that. GitHub for Windows, if you're just getting started, is actually a really, really good option. You just go to windows.github.com, I think is the URL. And it's a simple UI that rather than having this fetch and push and pull, it just has a button sync and allows you to sync changes across repos. Much, much simpler, quite a nice tool. So that's quite a good one as well. SourceTree by Atlassian it's reasonably good. It's better on Mac than Windows, but it supports everything. It can be a little intimidating when you first get into it. My preference, which is just personal preference, is I love Git extensions. It's kind of simple enough, but it's really powerful, lets me do everything I want. The visualizations are quite nice. And then, of course, the console. You saw my console had sort of the branch name in it, and it was colored and those sort of things. That's a nifty little tool called Posh Git, which gives nice Git integration, tab completion, that sort of stuff in PowerShell. So you need to install and configure Git. If you head to gitscm.com/download/win, you can download official Windows binaries now. As of like 2 months ago, we actually have official Windows builds that are built by the core Git team, rather than having Git building stuff for the Linux and Mac community, and then msysGit building their own versions. It's now actually, we've got proper releases. You can also install that by Chocolatey, which is choco install git.install. That'll get it installed on your machine. The first thing you have to do is make sure you configure your name and email address. Otherwise, when you commit, there won't be any authors or anything. It'll get angry at you. You can also use your favorite Git tooling. So inside Visual Studio, you can go to settings and you can set that stuff up. All your configuration can be done in there. To learn a lot of these concepts, there's also a really good tool called pcotl.github.io. But if you just Google or Bing for learn Git branching, it has all of these different sort of levels and tasks that you have to complete. And it'll give you a nice high-level view. There's no content. This is not a real Git repository, but it allows you to go through the fact that you have to create branches and then do a rebase and go through the command line options. And it gives you sort of, yeah, you completed this, and it gives you a lot of information. It's a really, really good tool for learning Git. So we've got about 10 minutes for questions. At the back.
In the Visual Studio IDE, included, excluded, and untracked.
Yep.
How do they relate to the Git?
Yep, so the question was, in Visual Studio, you've got included, excluded, and untracked. So your untracked are kind of files that it doesn't know about. So in Git, when you say add, which is adding on the command line, so git add, that's adding things into your index. By default, if that file has never been committed before, it won't get added when you say git add. It'll only add new changes of changed files. So that's that untracked. Git's just not looking at it because it's been a new file. Whereas staged is those changes have been added into my index. Unstaged is Git knows there's changes to that file, but if I commit, they're not going to be committed. And then untracked is you have to explicitly add that file and tell Git to start tracking it. So they're kind of the three states of the index. Is that your question? Cool. Right.
Are there ways to sort of encourage or ensure your developers to actually push regularly so their changes aren't just all sitting on their local machines?
The question is there a way to encourage your developers to push regularly? Because now I can commit on my local machine and not, and have that merge pain, I suppose, because I've left it out. Not really. There's a few techniques that I've used with pull requests around as soon as you start working on a feature, open up a pull request as soon as you've done your first commit and mark it as a work in progress. So then your team has visibility that there is work in progress. But those sort of problems are really come down to team conditioning and just making sure that people do the right thing.
Have you played with the multiple Git repositories in a TFS project?
The question was, have I played with the multiple Git repos inside a TFS project? No, but the UI, so in a single Git TFS repository or project, you can add multiple Git repositories into it, whereas with TFS version control, you can only have one TFVC for a single team project. The UIs for switching the repositories are a little bit clunky. They're constantly improving. I'm pretty sure the on-prem update for whatever update it is, update 1, is improving some of that. And there's also the feature that you can add Git repositories, additional Git repositories into a TFVC project. So if you've got existing projects which are using TF version control, from update 1 you'll be able to add Git repos in. So hopefully it'll get better.
Is it possible to use TFS version control and Git at the same time to transition slowly, or have you just got to cut over straight away?
Yep, so the question was, can I use TFS VC and Git at the same time? There's two open source tools. One of them is Git TFS, and I think that's the open source version. And it allows you to check out a TFVC repository into a local Git repository. Unfortunately, there's a few sort of issues. So if I commit 3 times and then I do a push, it will do change sets and then try and rebase to make things work properly. It's kind of messy. It's a lossy abstraction. So there's no real good way. You can sort of take parts of a project and clone just a folder out of TFS into a Git repo and then add that as a separate repo and then delete it in TFS. So you can sort of just take a project out of the entire repository at a time. So there are solutions, but none of them are particularly nice. There's a few guides around, so.
When you did that pull request,
Mm-hmm.
when you were looking at the differences, would that have, if another push had come in between the branch and the pull request processing, what are you looking at? Are you looking at merges?
So the question is I put up a pull request, I then create another commit locally, I push that commit. What happens to my pull request? So a pull request always tracks the head of that branch. So as as people comment on a pull request, it adds to the history. Pushing new commits into that branch adds that commit into history. And it has nice features, like if I comment on lines and then I push a commit that modifies the lines that were commented on, it'll automatically collapse those conversations because they're no longer relevant. So the idea of a pull request is to show the evolution of that over time. So it's not a snapshot when you first create the pull request.
You talked about workflows. Do you find, like when you're consulting, you promote, say, GitHub Flow? What's the preference with clients?
Yeah. Okay, so the question was, I talked a bit about workflows, but I didn't really go into any of them. When I go to clients, do I promote particular workflows? Yes, I do promote particular workflows. I tend to advocate GitHub Flow. And GitHub Flow is when you create a branch, push that branch up, create a pull request into master, merge it, then pull the changes down. So it's a one-way flow, and it's quite simple. There's another one called Git Flow, and Git Flow is another popular one, and the main difference is that instead of working on master, you work on a branch called develop. All your similar workflows create pull requests into develop, but then you create release branches, which then you stabilize and then merge into master as a workflow. So it's a lot more involved, and the only times I recommend those more advanced workflows is if you have to support multiple versions in production at one time, or you have active development on one release while you're stabilizing another release. So you've got sort of multiple teams working on a single product. Flows like Git Flow can be useful. I've actually got a side project called Git Versions, one of my open source projects, and in the docs, it covers these workflows quite well and how it works in with releases and versioning and those sort of things. So the docs of Git version is quite good for covering the workflows, and we've got a few flow charts on when you should pick each of them because we support all of them. So.
If you have a TFS repository, can we move it to Git, or is there an easy way?
Yep.
Git TFS, right?
Yeah, so there's no, the question was, if I'm using TFVC, is there an easy way to migrate across to Git? The answer, as far as I know, there's no sort of button to just convert repository, but Git TFS allows you to clone into a local Git repository. So the workflow tends to be, here's my Git repo, I'll clone it into a local Git repo, and what that does is it looks at every change set and creates a compensating Git commit, so you get full fidelity of your history. It just takes a long time. For big repos, it can take a weekend to do that. But once you've got that local Git repo, with update 1, you'll be able to add a Git repository into your TFS project and then push all of those changes into the Git repository without having to create a new team project, which is using Git. So in update 1, you can have both the TFVC and a Git repository in the same team project, which will help this. Cool. Out the back. Does the annotate command still work? So I actually didn't put that up. That's a feature I completely forgot. So the annotate command tells you who committed what line. Git has a similar feature, except it's called blame. Yeah, so git blame will do the same as annotate. What are the alternatives to GitHub? Okay, so there's a couple. I'll separate them into 2 categories. Hosted, so you want to host it yourself, and then, they're hosted for you, and then on premises where you do the hosting. So there's one called GitLab, which is an open source one. It does have a free open model, or you host it yourself. Bitbucket also supports, which is an online-only offering. It supports Git. And then Atlassian have Stash, which is an on-premises version of Bitbucket, it's actually quite a good product. Obviously, you have TFS for on-premises, and you have Visual Studio Online for hosted. And then GitHub is quite good for for either. They have GitHub Enterprise, but that tends to be quite pricey. They're the main options. I think there's a few others. There's Codeplex, which no one really uses, not even Microsoft. I think mainly GitHub is one for the moment. That's where the community is. For private projects, if you've got a team smaller than 5, I'd probably just use Visual Studio Online because it's free for teams under 5. Otherwise, you can pay GitHub to have private repositories. But, yeah. Anyone on this side of the room? Over there.
Because it's not tracking changes, do you end up with a large folder size?
Yep, so the question is because it's not sort of just doing deltas, it's taking snapshots of whole files, don't Git repositories end up massive? Yes and no. So that's at a simplistic level. So what Git does is it has heuristics internally that even if you've made a small change, it'll end up with all of these duplicates. It has another function, garbage collecting, which will go through and go, well, these are very similar. So in its internal object structures, it'll create pack files, which compress those down and then just have deltas. So in theory, it works the way that I have here, but internally, it has a bunch of optimizations to make that problem go away. Anyone else? I think that we're about time, so yes, Richard.
What should you do with binaries?
The question was, what should you do with binaries? And recently, Microsoft and GitHub have collaborated on a feature called large binary object. I forget the name of it. What's it called? I can't remember. It's a large file system. And the idea is if you've got a large binary object, which Git does not work well with, it can't do pack files and binary things and stuff, it allows you to have an external repository. And then if you check out a commit that's referencing that, Git will actually go and pull that binary from the other source into your local. So if you're committing large like DLLs and ISOs and other large things, it can put those out into another store somewhere. So.
What happens if the large binary doesn't change very often?
The question was, what happens if the large binary doesn't change often? It's still not ideal. Git just doesn't, it's all designed for text, so the transfer protocols and a bunch of other things just are heavy. So using things like NuGet package restore and the large binary object or large file system, whatever it is, using those things just to keep them out. And that's the other thing. When you're migrating from TFVC to Git, you probably want to rewrite history to remove those large binary files out of history, which you can do. Git allows you just to say, I want all the history except exclude this folder. And when it's cloning, it'll just exclude that folder. And I recommend doing that. So I think I'll have to call it there. And thanks, everyone. You can grab me in the speaker lounge.